Hello everyone, myself Shreya Chakravarti of USN 1VE21 CS163 is here to present a topic of Huffman's tree from the subject data analysis of algorithm. Points to ponder. First slide will be history. Second slide will be going through the introduction, then following by the behind the scenes, ways to create Huffman trees, example and thank you slide. So let's begin with the very first slide, that is the history of Huffman. In computer science and information theory, a Huffman code is a particular type of optimal prefix code that is commonly used for lossless data compression. The process of finding or using such code is Huffman coding, an algorithm developed by David A. Huffman while he was a SCD student at MIT and published in the 1952 paper, A Method for the Construction of Minimum Redundancy Codes. The output from Huffman's algorithm can be viewed as a variable length code table for encoding a source symbol, such as a character in a file. The algorithm derives this table from the estimated probability or frequency of occurrence, that is weight, for each possible value of the source symbol. Heading towards the next slide, that is behind the scenes. In 1951, David A. Huffman and his MIT information theory classmates were given the choice of a term paper or a final exam. The professor Robert M. Fano assigned a term paper on the problem of finding the most efficient binary code. Huffman, unable to prove any codes were the most efficient, was about to give up and start studying for the final when he hit upon the idea of using a frequency sorted binary table and quickly provided this method. The most efficient is doing so. Huffman outdid Fano, who had worked with Claude Shannon to develop a similar code, building the tree from the bottom up guaranteed optimality, unlike the top-down approach of Shannon-Fano coding. Ways to create Huffman tree. There are mainly two major parts in Huffman coding. First, build a Huffman tree from input characters. Second, traverse the Huffman tree and assign codes to the characters. Steps to build Huffman trees. First, input is an array of unique characters along with their frequency of occurrence and output in Huffman tree. Second, create a leaf node for each unique character and build a minimum heap of all the leaf nodes. Min heap is used as a priority queue. The value of frequency field is used to compare two nodes in minimum heap. Initially, the least frequent character is at root. Third step, extract two nodes with the minimum frequency from the minimum heap. Step 4. Create a new internal node with a frequency equal to the sum of two nodes' frequency. Make the first extracted node as its left child and the other extracted node as its right child. Add this node to the minimum heap. Repeat step 2 and 3 until the heap contains only one node. The remaining node is the root node and the tree is complete. The terminology used in Huffman coding. Huffman coding uses a specific method of choosing the representation for each symbol, resulting in a prefix code, sometimes called prefix-free codes. That is, the bit string representing some particular symbol is a never a prefix for the bit string representing any other symbol. Huffman coding is such a widespread method of creating prefix codes that the term Huffman code is widely used as a synonym for prefix code, even when such a code is not produced by Huffman's algorithm. Problem definitions. Informal description. Given a set of symbols and their weights usually proportional to the probabilities. Find a prefix-free binary code, a set of code words with minimum expected code word length, equivalently a tree with minimum weighted path length from the root. Formalized description, input alphabet A is equals to A1, A2 till AN, which is the symbol alphabet of size n. Tuple W is W1, W2 till goes to Wn, which is the tuple of the positive symbol weights usually proportional to the probabilities. That is, Wi is equals to weight Ai. I belongs to set of 1, 2 till the nth term. The output of this description will be code C containing the tuple W and C1, C2 till Cn, which is the tuple of binary code word, where Ci is the code word for Ai. I belongs to the set of 1, 2 till the nth term. Example, we give an example of the result of Huffman code for a code with 5 characters and given weight which we will not verify, that is a minimizes L over all codes. But we will compute L and compare it to the Shannon's entropy H of the given set of weights that results in nearly optimal. For any code that is biuni, meaning that the code is uniquely decodable, the sum of probability budgets across all the symbol is always less than all or equal to 1. In this example, the sum is strictly equal to 1. As a result, the code is termed as a complete code. If this is not the case, one can always derive an equivalent code by adding extra symbol with equivalent associated null probabilities to make the code complete while keeping it biunique. As defined by Shannon in 1948, the information contained H in bits of each symbol AI with non-null probability. Hope you liked the video. It was informative enough. If you are new to my channel, please subscribe to the channel, like, share and comment. Don't forget to share.